Hey everyone, and welcome. So today we're going to tackle a word you hear thrown around all the time, especially in medical dramas: shock. And no, I don't mean the jump out from behind a door kind of shock. We're going to break down what medical shock really is: a critical failure of the body's most important service, where every single second literally counts.
But to get us started, let me ask you a question. Just think for a second. What is the single most critical, most time-sensitive delivery service in the entire world? I mean, one that absolutely, positively cannot be a second late. You guessed it, it's your own circulatory system. It's this incredible, non-stop delivery network that's working 24/7, shipping the most vital package there is, oxygen, to every single one of your trillions of cells. And when that delivery service fails, well, that catastrophic failure is what doctors call shock.
Okay, so let's really dive into this. What exactly is shock? You know, a lot of people think it just means low blood pressure, but that's really just a symptom. At its very core, shock is what we call a crisis of perfusion. It's a failure to get enough blood and oxygen out to your tissues.
So here's the official definition. It's a life-threatening breakdown of that oxygen delivery service we were just talking about. When cells don't get oxygen, they begin to starve and suffocate, a state we call hypoxia. The crazy thing is, this is totally reversible if you catch it early enough. But that window closes fast, and it can quickly lead to permanent organ damage and, well, worse.
Now, what's so fascinating about these signs is that they aren't just the system failing. No, this is the body's desperate, all-out attempt to fix the problem. The heart starts beating faster. That's tachycardia, trying to pump whatever blood it can. You start breathing faster, tachypnea, to pull in more oxygen. These are the body's alarm bells, signaling that it is fighting for its life.
And you know, shock isn't like flipping a light switch. It's a progression, a downward spiral. It starts with pre-shock, where the body's still managing to compensate, and you might not even notice much is wrong. But eventually those defenses get overwhelmed, and you enter true shock. That's when organs start to fail, get to that last stage, and the damage becomes irreversible. It's all about time.
So how can we possibly wrap our heads around all the different ways this system can fail? Well, believe it or not, it all comes down to one single, really elegant equation. If you can get this one concept, I promise you, you can understand every single type of shock out there.
This is it. This is the master key. Mean arterial pressure, or MAP, is just a fancy term for the average pressure pushing blood to your organs. And it's only decided by two things: cardiac output, that's how much blood your heart pumps out, and total peripheral resistance, which is just how squeezed or relaxed your blood vessels are. That's the whole game.
And this is where it all just clicks into place. Just think of it like the plumbing in your house. Your mean arterial pressure, that's the water pressure. Your cardiac output, that's the power of your water pump, your heart. And total peripheral resistance, that's just the width of your pipes. If the pressure is low, you've either got a pump problem or a pipes problem. Simple as that.
So what's the magic number? What pressure are doctors shooting for? It's this one, 65 millimeters of mercury. You can think of 65 as the absolute baseline. If your mean arterial pressure drops below that, your vital organs, like your brain, your kidneys, they're just not getting the blood flow they need to survive. The delivery service is officially failing.
Okay, so now that we've got this awesome tool, our pressure equation, we can use it to understand the four main ways shock happens. Each one is just a different way for our pump and pipe system to break down. And here they are, the big four: hypovolemic, cardiogenic, obstructive, and distributive. Now, they all sound complicated, but just remember, each one is just a unique way of breaking our pressure equation. But they all end in the same place: not enough oxygen getting delivered.
But honestly, we can make it even simpler. It really just boils down to two fundamental problems. The first three types you see there, hypovolemic, cardiogenic, and obstructive, are all basically a pump problem. They mess with cardiac output. The last one, distributive shock, that's a pipes problem. It messes with peripheral resistance.
So first up is hypovolemic. Hypo means low and volemic means volume. It's low volume shock, plain and simple. This is what happens with massive bleeding or severe dehydration. In our plumbing analogy, there's just not enough water in the system for the pump to move around. The pump's working fine, but the volume is too low, so cardiac output just tanks.
Next up, cardiogenic shock. Cardio means heart. This is pure pump failure. This time, the volume is fine, but the heart itself is broken, maybe from a heart attack. The pump just can't generate enough power to push blood through the pipes, and again, your cardiac output plummets. Obstructive shock is also a pump problem. but it's a mechanical one. It means something is physically blocking the heart. Think of a huge blood clot in the lungs or fluid building up and squeezing the heart. The pump itself is healthy, but it can't do its job because it's being blocked. Once again, cardiac output drops like a rock.
All right, now for the one that's totally different. In distributive shock, you've got plenty of blood volume, and your heart is pumping away just fine. So what gives? Well, here the pipes are the problem. This type of shock breaks the other side of our pressure equation. And this slide shows the three main culprits. Whether it's septic shock from a massive infection, anaphylactic shock from an allergy, or neurogenic shock from a spinal injury, the body loses control of its blood vessels. They all dilate, they just open wide all at once. It's like your pipes suddenly became massive and now there isn't enough fluid to fill them. Your peripheral resistance and your blood pressure totally collapse.
So, when a patient shows up in shock, the clock is ticking like crazy. It's an absolute race against time. How do medical teams figure out which of these problems is happening, and more importantly, how do they fix it?
Well, it's immediately a flurry of activity. They run a whole battery of tests at once. A blood count looks for bleeding or infection. An ECG and an echocardiogram look directly at the heart, our pump, to see if it's the issue. It's like detective work, but at lightning speed, all to find the point of failure in our pressure equation.
And the treatment is this brilliant two-pronged attack. First, you have to stabilize the system. That almost always means pumping in fluids and using medications to crank the blood pressure back up. Basically, just get that delivery service back online. But at the exact same time, you have to be aggressively hunting down and fixing the root cause, whether that's antibiotics for an infection or rushing to surgery to stop bleeding.
Which brings us to one final thought. We've established that shock is a failure of oxygen delivery, a desperate race against the clock. So what does that tell us about the absolute critical importance of the first few minutes of any medical emergency? The first aid given, the first call for help? It tells us that those early moments aren't just important, they can be everything. Thanks for joining me.